Okay, so in this video, we're going to look at how to set up the routing tables. So the routing. Okay, so in this video, we're going to look at how to set up the routes and the routers here to communicate from one LAN. So basically, here we have some PCs in this LAN, two PCs in this LAN, and the two LANs are separated by a sequence of two or more routers. So this could be a good example of how you make this RIP protocol to configure routes, the routing at the routers, so that we can have this kind of communication between two VLANs separated by two or more routers. That's the goal of this video. So I'll make a screenshot of this layout, and we're going to set it up again. I'm going to show you how to set up all these things, and a similar assignment will be given to you. Okay, so let us get started. Okay, so we need to first set up the two LANs. So for that, we need a switch. I choose this 2960 switch. Then we'll put two PCs in this LAN. So this LAN is going to have network address 192.168.1.0. Let's connect these two PCs to the switch. So we're not going to do any VLAN here, just simple LAN-based configuration. Okay, and they're going to be, the switch is going to be connected with a router. So we'll choose a 2911 router. And let's connect the switch to that router. So it's connected to interface. You click on that, you're going to be 0/0. That's the interface which you're going to connect it. So if you place a mouse on that, it's going to show the interface. Okay, so let's configure it a little later. Let's put the LAN on the other side. We'll set up the topology first. So we'll put a similar switch 2960 on this side. And let's put the two PCs here. Make them to the switch. Again, make sure you click on that thing to set up to get this cable connection. So this is going to be, say, 192 dot, what do you say, dot 2.0. Let's zoom things a little bit. Let's put the router there. Uh, so, right, let's put the intermediate routers we want, say, somewhere in between. Two intermediate routers. Okay, let's connect these routers as well. So you don't need to have an intermediate network to connect to routers. You could connect to routers like this through the kind of long distance links and put these two routers as part of a separate subnet or network. So we could say these two routers are in 192.168.3.0 network. Let me see if I can zoom it a little bit more. On Zoom things. Let's do this. All right. So this is then going to be in 192.168.4.0 network. And this is going to be in 192.168.5.0 network. Okay. All right. So let's, so as convention, the router gets the first available IP address for a network. So this becomes the gateway router for this LAN. So we are going to assign this router interface 192.168.1.1. Okay, so you can go to the router, click on config, and this interface is where we have the this link connected. So make sure to set the port status on, and it's going to get 192.168.1.1, and the subnet mask will be accordingly set. Okay, so let's close it for now. Let's configure the two PCs. Go to desktop, IP configuration. Let's use static IP address 192.168.1. Already gave 1.1 to the router, gateway router, so it needs to be 1.2. And let's set the default gateway to 1.1. Okay, now for this one, it's going to be desktop IP configuration 192.168.1.3, and the gateway is 1.1. Okay. Now you can do a small ping to test the connection within this LAN. Say ping 192.168.1.3. This is from 1.2. That's PC0. So you're getting a reply. You should be able to ping the router also and get a reply. So everything is fine with this LAN. Let's do a similar thing here. So this interface would be to place a cursor here, the 0/0. So this router interface, config 0/0, port status on, will get 2.1. So 192.168.2.1. And this PC could then get 2.2 desktop IP configuration, 192.168.2.2. And 2.1 will be the gateway address. And this one would get 2.3. That's it. So you can also similarly test the connection in 192.168.2.3. This is from 2.2. As well as you can test connection to the router, you're getting a reply. Okay, so now let's set up the intermediate LANs. So this interface is 1/0/1. So that will get 192.168.3.1. So 0/1 interface, make sure to set the port status on 192.168.3.1. And this interface would get 0/0 for this one, would be 3.2. So config 0/0 port status on. Okay, so that should set up the connection. Now this is 0/1, that should get 4.1. 0/1 should get 4.1. And this interface is 0/0 for this router. So that should get 4.2 corresponding to this. So 192.168.4.2. Now this interface is 0/1. That should get 5.1. And this interface is 0/1 for this router. That should get 5.2. Okay, so 0/0 is already 5.2.1. All right, so everything is being set up. So we have to now set up the RIP protocol at each router. So let's go to this. So the RIP protocol, so is RIP, this is it learn routes once you set up the networks connected to this router. So there are two networks connected to this router, 192.168.1.0 on this interface and 3.0 on this interface. So you don't need really the interface, just type the network address. Since you already configured interfaces with the corresponding addresses, it will figure out what each of these networks correspond to which interface. Click add, then 192.168.3.0 corresponding to this network for this router. That's it. So you could go to settings and make sure to save it, just to make sure everything is saved. And for this router, click on RIP. The two networks are 3.0 and 4.0. So let's add them, 192.168.3.0 and 192.168.4.0 add. Go to settings and save. And for this router is 4.0 and 5.0. So click on RIP 192.168.4.0 and 192.168.5.0. Settings, save. And this interface, this network, RIP 192.168.2.0 and 5.0. Click on settings, save. So it should be now fine. So let's test the connection from this 1.2 to 2.2 if you want, you can do that. So command prompt. So ping 192.168.2.2. Getting reply from that PC. Let's try from say this one to this 1.3. It may time out in the beginning and eventually we'll get it. Yes. Okay. So this is a round trip time for the message to come back or reply. So ping is basically you're sending a request message from this PC to this PC to test whether it's alive. It is alive, so it's sending back a reply. So it takes 11, 12, 14 milliseconds to traverse through all these routers, intermediate routers as well, and come back to this initiating PC. So that's the round trip time. Okay. Now, let's try from this. Yeah, okay. Now, if you notice here, the TTL is the time to leave field. We will see here more about that in the next module on IP headers, but it could be set to 128 and it's decremented by 1 at each router as it goes through. So from 128, it will be decremented to 127, then 126, then 125, 124. Similarly, for reply coming back from here, it will be initially 128. At this router, it will be 120, decremented to 127, then to 126, then to 125, then decremented to 124. So that's why you see the reply, the TTL is basically 124. So it starts at 128 most of the time and is decremented by 1 at each intermediate router. Sometimes it could be set to 256 as well. But based on the number value, it's either 124 or 252, you should be able to determine the number of intermediate routers it has gone through. So if it's 124, it's close to 128. So from 128 to 124, it has been decremented. So there are 4 intermediate routers on the way from between the 2 machines. That's what it means. If it is 252, that means most likely it has been set to 256. So 256 minus 252 would be then 6. That would be 4. So this TTL field is typically 8 bits long. So it could be set at most to 255 actually, not actually 256. So let me make that correction. So it could be at most set to 255, not 256 with all the 8 bits on. But if it could be set to 128, so if it's showing up in the range of 120s, then it means it has been set to 128 and it got decremented by 1 at each router. So if it is 255, so if it is 124, then more likely it has been set to 128, so the difference is 4. If it is a 252, more likely it has been set to 255, not 256, and the difference is 3. So that's what I wanted to convey. And this 4 or 3 is the number of intermediate routers through which the message has gone through. So let's do one more thing here. Let's set up another LAN here. We'll go through this switch here, one more switch. And just set one PC. Let's connect things up first. So this is going to be 192.168.6.0 network. So we can set this is going to be 10/2 interface, 3 interfaces for the 2911 router. So this interface 0/2 will get that 192.168.6.1 gateway address. And we can set that to this PC's gateway address. 192.168.6.1, and the IP address could be 192.168.6.2, and the corresponding subnet mask will be set up. So this router should now learn. So one other thing you have to make sure is to this router's RIP network, you have to add that 192.168.6.0 network. Make sure code settings and save it. So routes to this LAN will be learned. So let's try to ping 192.168.6.1. The reply is coming from there. So we did this ping from this PC3 and got the reply. So let's try it from here. I think I might have to make a correction. It is 254, but there are 2 intermediate routers, right? So even with this, we got 3. So it could be 256. So Let's change it. So it should be 256. Okay, so you see here in this case, you got 254. I did a ping from here, so it goes to two intermediate routers. So, and it's 254 now, so it makes sense to say it is 256 minus 254 is two intermediate routers. Similarly, when we did the ping from this PC, you notice that we got 253 here, and that's because it went through 1, 2, 3 intermediate routers. So it is three intermediate routers, 256 minus 253. So let's keep this as a final thing. So if it's close to 250s or 240s, it is then 256 minus whatever that value is. That's the number of intermediate routers. If it is a 120s or 110s, then it's close to 128. So 128 minus 124 in this case is 4 again. That's the number of intermediate routers the packet goes through. So that's the kind of thing I'll ask you to do in the assignment, setting up this topology. Each student will get a separate network address for all these different networks. And you should be able to configure these and show the communication, the ping communication. So you could save this as a packet file. So save as a packet file. Multi-router communication dot package status packet file, and should be uploading the packet file in Canvas. Okay, that's all you may have to submit. So I will test it out to see if you have configured it correctly, so that I can communicate from any one PC in a LAN to a PC in a different LAN. Okay, so let's stop the video with this.